Good morning or good afternoon, everyone, depending on where you're joining us from today. I'm going to get started in about 1 minute. Some folks are still getting into the webinar here, so just hang on for 1 minute and we'll go ahead and get started. Thank you. All right. Well, good morning again. This is Mike Mazzarese. I'm a senior engineer with AST Environmental. And the topic for today's presentation, which is the last in our winter series for 2020, the pre-drill methodology overcoming unconsolidated DPT refusal. All right, so as I mentioned, this is the last in a 6-part series that kicked off back in early November. And so you can see the topics and the dates here. You'll notice down at the bottom that all of these are housed on the RPI website, which is www.trapandtreat.com. If you have any questions or you can't find them, please reach out to myself or Bob Elliott. I'll provide those emails at the end of the presentation. So we kind of walked through a couple on the front end before the Thanksgiving holiday here in the US. We covered the individual technologies, and then here in early December and last week we covered characterizing and injecting into fractured bedrock. And so here we are today talking about what we call the pre-drill methodology. All right, so before we get started here, just kind of to define what I'll be referring to as the RPI Group as we go through this presentation. So up at the top, we've got RPI, Remediation Products, Inc., the guys that develop these technologies and also operate our project support laboratory. There goes their website. AST Environmental, company that I work for, we are tasked within the group to assess projects nationally and internationally, also provide quality control for the RPI Group, and we're also an installer of the technologies as well. There's our website, and then lastly, the third leg of this the RPI Group stool here is our authorized installer network, and so these are a group of companies around the world that have made the investment in the proper equipment and training for the personnel to be able to implement these technologies properly. Okay, so here's a footprint of where we've worked. Most of the lower 48, Alaska, most of Canada, a bunch of countries in Scandinavia, and there's some others down there at the bottom in Europe, Australia, South Africa, and Puerto Rico will be have a couple projects implemented there once we get on the other side of COVID. All right, so before I start here, so we've got a couple poll questions that we've got to ask that are tied to being able to provide credits for certain organizations. So I'm going to go ahead and pull one up here, and then we'll wait about 45 seconds or so for everyone to respond. All right, great. I'm going to go ahead and close that. And so we got about 90% of you with 82% voted. We've got 90% as yes, you have hit refusal shallower than your target depth whenever you've gone out to a project site. So thank you for that. All right, so first off, before we kind of get into the technique a little bit, I'd like to talk about the difference between liquid and slurry injections, because I would say most people are more familiar with liquid injections. And so talking about chemical oxidants like sodium permanganate, sodium persulfate, for example, hydrogen peroxide. I've got emulsified vegetable oil here as well. And so those are generally applied under low pressure, low flow conditions. And so maybe if you're using direct push or injection wells, you can manifold a bunch of those together, really flood the pore space and try to fill up that bathtub, if you will, right? And so whenever you do get direct push refusal, what are your options? I'd say, the go-to would be to install an injection well. And let's say, injection wells generally, if you've got to go greater than 10 feet, you're probably gonna nest those into different intervals. The problem with injection wells is that they don't focus, right? So besides that 10-foot interval, so if you've got a variable geology, if you've got higher and lower K zones that span that interval, and the mass is in those lower K zones, it's going to be really difficult. Maybe over multiple applications, you can get some diffusion-based transport into those lower K zones, but it's going to take some time. But it's has been done. For slurry injections, it's a little bit different. So talking about like trap and treat, so activated carbon-based technology, zero valent iron would be another example. You can't use injection wells. And so we're talking about higher flow rates, pressures, and energy required to be able to get that material properly distributed in the subsurface. So this is really the core reason why us at AST that work primarily with these activated carbon-based technologies had to work with the RPI group to develop a methodology to be able to use direct push and the techniques that we use in the overburden in these zones where we do get refusal. And what came out of that is what we call the pre-drill technique that we'll be covering here in a few minutes. And so I'm not going to get into these individual technologies here today. I just wanted to throw this up here because they are going to be referenced when we get to the project summary section. So BOSS 100, CAT 100, these technologies are used primarily for chlorinated solvents. It's what you would think of in a traditional granular activated carbon. Down at the bottom, BOSS 200 and 200 plus are used primarily for petroleum hydrocarbons, and that's more of a powdered activated carbon. All right, so these are the four main techniques that we use to get these technologies in the subsurface. So vast majority of our projects are going to be traditional direct push, where we don't get refusal. Say top-down injections. We like top-down, whether it's pre-drill or whether it is, whether it's not, whether it's traditional direct push, just because you're pushing down into native material. If you bottom up, I don't think is a good is good practice for most applications, because especially when you're in something fine-grained, as you're drawing that injection tip up and you're pulling your rod string out in a bottom-up fashion, you're leaving a void below that rod string, and I think a lot of times you do get bypassed down into that lower borehole that you've just vacated. So you alleviate that as an issue when you use the top-down manner. And what's your variables there, so whether you're in a clay or a sand, for example, might be your injection volume. Maybe your injection tip is actually going to change. We change those quite a bit as well, depending on the lithology, try to match them up as best we can. I'm going to skip over pre-drill and then I'll come back to it. Bedrock, those were, if you've got fractured bedrock sites, I encourage you to download or listen to the webinars that my colleagues gave early in first week and the second week in December on talking about characterizing and injecting into fractured bedrock. Bedrock applications, as well as these pre-drill applications, are some of our growing markets for us at AST, and I think that's because we're left with a lot of these really difficult sites where maybe the shallow mass has been dug up or it's been dealt with using other technologies. Lastly, down at the bottom, soil mixing, always a great application, whether you're doing an excavation and you just want to blend in the bottom few feet, or if you have a chance, if you're putting a PRB in and it's shallow enough to be able to trench it in, you'll never get better distribution than you do whenever you use a soil mixing technique. So go back up to that second bullet for the pre-drill. Again, we're using a top-down manner there, and we'll get into it here in a little bit, but it's really using sonic or augers primarily to be able to pre-clear that borehole, just like you would for utility. So instead of using an air knife going down to 5 feet, we're using one of these other traditional drilling techniques to advance our boring all the way down to our total depth, and then we'll get into what we do afterwards before we come back out and use direct push. So here's an example of just a standard direct push setup out on a gas station. So this is the pre-drill out on a site. It's actually the third project summary that I'll get into. This is Shaw Air Force Base down in South Carolina, using the geoprobe sonic to be able to pre-clear those holes. Went down over 170 feet down on that particular site. Here's just a photo of the straddle packers that were referenced in the previous presentations. And then lastly, here's this is a site in Pennsylvania where I'm originally from. We're trenching in a shallow Boss 100 PRB to cut off a chloroform plume. All right, so all of these presentations that you see that talk about injection techniques, they all have the same kind of common element, and they talk about contact, right? And contact being critical and king for these applications. And so, it really is true, right? I mean, if we don't get, especially with slurries, because they're not going to move once that injection energy dissipates, the injectate isn't going to move, which is what you want for most applications. Like if you're putting a PRB in, you wouldn't want to put something in that's going to be mobile, right? You want it to stay in place. And so, as we've talked about, DPT by itself and packers not always options. That's why we're here today. And injection wells. I mean, if you're looking at slurry-based technologies, injection wells aren't an option. And if you are looking at more solution-based injectates, really look at, use that RDC process that's been referenced in previous webinars to be able to really ID where your mass is, where it sits in that vertical column, because if it is tied up in those lower permeability zones, it might be difficult to treat with injection wells. All right, so where have we used this? And I'll actually show you a map of the US and Canada here next, of the states where we've used this technique. And you can, if you've drilled around the country, you probably can guess which one of these is tied to the individual states whenever we get to it. But depending on where you are, it might be a glacial till situation, or it may be a weathered bedrock or a saprolite. Maybe just be historic fill. That's the first project summary that I'm going to show you. Is actually a historic fill situation. And so again, it's pretty simple. We're going to be advancing, say, augers or sonic down to our total depth. We're going to backfill with bentonite. It's a pretty specific, it's a really detailed procedure. You want to do it in pretty tight lifts. Make sure it's hydrated. Make sure it's hydrated well. And usually we let it sit about 24, 48 hours on the minimum end before we come out to be able to re-drill that location with direct push. So our injection fluids cut through that bentonite and get into the native lithology. And so that's one of the main questions we get is, well, are you just going to have a giant tube of toothpaste and you're squeezing all this bentonite out of the top? And the one thing that I will caught, we haven't used this technique on really shallow applications. So if we're going to be using this at say less than 10 feet, we really haven't used that, or at least not that I'm aware of. So most of these applications are deeper. So that is the one caveat. But if you think about it, what's coming out of these injection tips looks like a pressure washer, and it's going to slice right through that bentonite and get out into the native material. So the one place that I would caution you is that this is not transferable to liquids. I know of at least one site where that was attempted and it failed. It wasn't AST that did it. It was another company came out, tried to use this technique to inject, I think it was an emulsified vegetable oil. It did not work because, again, you're trying to go low pressure, low flow, and that's where you may have that tube of toothpaste situation. And so I would only recommend using this for slurry applications. And we've done about 40 sites around the US and Canada to date, somewhere between 40 and 45. And so I'm going to go ahead and pull up our second poll here. All right, so this is our second and last poll, and just go ahead and click the different situations where you have gotten refusal. All right, most of you have voted. We're at about a minute here, so I'm gonna go ahead and close that out. And so you can see the results there. A lot of you have fill material, I'd say, fill material, weathered bedrock / saprolite. Glacial till, we're all over 50%, hard pan close to it, and then caliche about 27%. So again, thank you for those responses. And so let me get you that. So here's that map of the U.S. that I talked about, where we have done pre-drill applications. And so you can kind of, again, that's why I was, depending on where you're drilling within the States or up in Canada, where we've used these techniques, you can pretty much guess which one of those situations you're in. Obviously, Washington State, glacial till, Canada, same. Southeast, more of the weathered bedrock saprolite, same thing in Pennsylvania. Caliche down in, say, Texas. And so we've used this in quite a few states across the U.S., as well as in 2 provinces up in Canada, and in Ontario and BC. And so everything's the same from an injection point layout standpoint. We use a triangular grid when we're doing source or plume treatment. We're using triangular grid patterns. Spacing is usually 7.5 to say 10 foot on center. And for PRBs, very much the same, 3 to 5 feet, or sorry, 3 to 5 injection rows with 7.5 to 10 feet on center here as well. And the deeper we go, depending on the site, that spacing is on, the shallower we are, the tighter the spacing is, the deeper we are, spacing can be relaxed a little bit. All right, so we'll go ahead and jump into the summaries here. So I didn't mention this on the front end, so I apologize. Any questions you have, please put those off in the taskbar off to the right. And my colleague Derek Pizarro is going to collect those, and when we wrap up here, we'll go ahead and get into a Q&A session. So this first site is up in the Northeast US. You can see here we've got different phases of the project: pilot test, full scale, and the full scale extension between mid 2015 and early 2017. That's a photo of AST out on site doing the application. So each of those pads that you see here, these are all the pre-drill locations. All right, so it's a rest stop up in the Northeast. And when this area was being brought up to grade, they brought it up to grade with a lot of construction debris and blast rubble, and so not very direct push friendly. And the goal was to set up a PRB to protect this wetlands that sits to the north on the down gradient side of our barrier. So each location was pre-drilled by our client using sonic down to competent bedrock. And one note when we get into looking at the data for this site, this is our up gradient well, MW204. This well here, MW205, it was our original compliance well, or our down gradient well, excuse me. And it's where we did our pilot test, but it got consumed by the full scale whenever we did that. So that got abandoned, and our client installed MW207. So whenever I show you the data for this, this is our early data for the site, and this is our long-term monitoring well. So it was about 150 feet long, 88 injection locations on an approximate 7.5 foot spacing. The injection interval varied quite a bit. The contour of the bedrock varied, as you can see, from 26. Total depth was between 34 to 57 feet BGS, which is where bedrock was encountered. And the P, so flow, pressure, flow rate, and volume, to give you an idea of what the injection pressures looked like, what the injection flow rate looked like, and what that volume looked like per interval. And so if you're not familiar with how we do applications, in general, we're between an 18 to 24 inch spacing in between our injection intervals in any one location, and then we offset half that distance in the adjacent point. So if you're doing, say, 2 foot intervals, one point would be injecting, say, on the even depths, and then the adjacent point would be injecting on the odd depths. And on this site, it was a 2 foot spacing. And again, as you can see here, we were injecting 40 gallons per interval. Here's just another photo of the site with no equipment, so you can see the PRB in place. Then one of the nice things about, so when you're installing, when you're using this pre-drill technique and you're putting a PRB in, and you're using a technology that uses bio, so BOS 200 in this case uses bacteria, and so if you don't have a long-term term electron acceptor flowing through naturally, so something like sulfate or oxygen, then you may have to come back and supplement your barrier over time. And so if you leave these locations in place, you should be able to come back and re-drill them. So the only caution I would have is if you're going to go out and do that and it's been sitting there for a while, you may want to go out and just make sure that you may have to come out with a larger direct push unit than you originally came out with, just because that bentonite has set up a little bit. So here's the data for the site. So looking at it, here's where we did our pilot test at day 0. Here was our full-scale application, the solid line, and we've been in long-term monitoring since. The blue represents the total BTEX that's coming into the barrier, so that's that MW204 that I mentioned. And before the full scale, we were using that MW205. Since full scale, we're using MW207 as our downgraded monitoring point. So you can see we had about an average of 500 to say 1,000, 1,250 on average, a couple outliers up and down for your total BTEX. And what this orange line represents what's coming out the back end of the barrier. So the barrier has been performing very well. We're monitoring the electron acceptors, may need to be recharged, although they do have a kind of a reasonable sulfate concentration naturally coming through the barrier, so it may actually sustain itself long term. But it's something that we're monitoring. Second site, this is a chlorinated site. This is also another site that I was involved in. So this is a former Atlas site that's in Nebraska, and so we were looking at a suspected DNAPL area around what you'll see on the map here. I'll show you in a second. It's MW18, really high TCE in groundwater, but a very localized area. And so we were looking at a perched groundwater table, which was around 50 feet BGS. It was a low plasticity clay till with shallow DPT refusal, which is why it got converted to a pre-drill project. And we were looking at pilot testing, so it was a relatively small project, but it was looking to pilot test BOSS 100 for delivery, but also effectiveness in this area. And so I really haven't gotten into the RDC process in this presentation. It's been referenced in previous presentations that we've given. That's just our CSM refinement step of doing some high density soil and groundwater sampling to be able to refine our design. And so out on this site, we installed 4 monitoring wells, 1 CMT, that's the multi-channel well. So we installed 7 channels from 22 to 70 feet. And we sampled every 2 feet vertically at all these locations. So we sent about 115 soil samples to the RPI Project Support Laboratory. If you're not familiar with the laboratory, it supports our projects, offers the analyses pro bono. So if there's something you're interested in, if you have questions about that, please reach out in the Q&A, and we can field those questions then. All right, so this was our injection layout. So we had different spacing, 5, 7.5, and 10-foot spacing, depending on where we were. Total of 21 injection locations. So we used hollow stem augers to do our pre-drill. So we had 14 of our 21 points went down to 70 feet, and we had 7 points go down to 54 feet BGS, and about 7,500 pounds of BOSS 100 were injected in April of 2016. And so the pilot test, you'll see the data was pretty, we had a bunch of samples right after we completed the pilot test, which is the dashed vertical line. And that's all the sampling that was included in the pilot test scope of work. And so the site sat for a while, and we did get another sample late last year. And we were able to show we got about a 99.4% reduction at 1,300 days from our pre-injection RDC baseline concentration. So we have about 88,000 ppb of TCE baseline. And MW 27 and 28, to go back to the map, these are the wells that are on the on either side of our injection area. So they were outside our target area, but you can see that we did have some influence there, between 46 and 90% reduction. Those wells were really on the outside of our ROI. We did see some hydraulic influence there, but they weren't the focus of the pilot test. That was really MW 18. But we did see some did see some aerial effects outside of the pilot test area. All right, lastly, wrap up here with this project at Shaw Air Force Base. I already mentioned this earlier in the presentation in one of the photos that I showed. So this project had 2 phases to it. The first one was really that RDC phase that I mentioned in the previous project. It was just plume and CSM refinement to really update the design, the vertical horizontal extent, and that was done in early to late 2018, and then in later that year, 2018, up and through early 2019, we came out and installed a 650-foot BOSS 100 PRB that was installed, depending on where you were out on the PRB, 90 to 167 feet. So this represents our deepest pre-drill point, or our deepest pre-drill application, excuse me. So we use Sonic out there to pre-drill 130 injection points down to those total depths, and about 60,000 pounds of BOSS 100 was applied through those pre-drilled locations. And so, as you can see, as the topography drops here north to south, down in the southern end of the PRB, the injection intervals were shallower, so 90 to 122 feet BGS. And on the northern side, where the slope comes up here, we were deeper, 135 to about 165, 167 feet BGS. And so we were injecting the top 30 feet on top of this 100-foot clay in this upper Black Creek aquifer. Okay, so I mentioned 130 points. So just logistically, we We had 2 rigs out there that were operating simultaneously with the injection activities. So what we usually do when we're on a large site like this is we'll get the sonic rigs out there a few days ahead of us, let them get some points done, and then we start coming in behind them. So there was full logging on 10% of those locations, and there were samples collected from the bottom 30 feet. Those go into the RPI laboratory. And on this site, because of the depth, we didn't use, on most shallow sites, we're using bentonite for the total span of our boring. But on this site, you fill the bottom 70 feet with bentonite pellets and the balance with a 30% bentonite grout. And so here's us doing the actual injection phase. So again, about 60,000 pounds of BOSS 100 was injected into that UBC unit. And again, it's on the upper end. The shallowest end was 90 feet, deepest was 167 feet. We were using 2¼ inch rods to inject in that bottom 30 feet. And here's some photos from the project. And I think we're about 35 minutes in, which is right on schedule for this. So I'll go ahead and bring Derek in to start the Q&A session.
Hey, Mike. Hey, Mike, nice job.
Thank you, Derek.
So if you haven't entered questions for Mike, you could do so in the chat. You can do so in the questions box. Also, thank you to everyone who participated in the 2 polls. That was some really interesting data there. We'll give people some time to enter some more questions, but we've got about 4 or 5 already. So I'll get started with what I think is a pretty good question to kick us off here. And so Mike, when it comes to pre-drill, what is your typical daily production rate?
Is that on the injection side or on the pre-drill side?
Not specified. I believe it's trending towards the production of installing the bentonite column, so the preparation.
Right. So I mean, it's going to be, obviously, technique specific. Whether you're using sonic. Most sites, I would say it's probably been 50-50 augers and sonic. It's going to depend on the individual project. Everyone here knows kind of the pros and cons of those 2 different techniques. I guess looking at that Shaw site, which was one of our larger applications. Pretty sure now I was on this, full disclosure, I'm not the PM for that project, but I think they were doing 2 of those a day down to that 150 feet. So you're talking about 300 linear feet a day. So obviously I'm probably on the higher end because they're not moving around a lot. Actually, I'm involved in a project right now that's going on in Texas. It was originally thought it was a traditional direct push application, but it has since morphed into a pre-drill site. And we're going down 30 feet. I think they were doing about 10 a day for the augering and the backfill. So I think that's to give you an idea on kind of how much you can do. I would talk to your based on the local conditions, talk to your local driller as to what they think that they can do. The only thing that's going to add time beyond what you're normally used to is probably adding a little bit more time to that bentonite addition and the hydration process. Again, we're pretty anal when it comes to that process because we don't want to have any bridging when we come in and try to pressurize. When we pressurize that injection tip, we want to make sure that material is going horizontally and not coming up vertically back up the annulus of that borehole.
Great. And this kind of ties into it. What's the deepest site you've ever used this technology on? I think you might have mentioned it earlier.
Yeah, that was at Shaw Air Force Base, and so it was about 170 feet BGS. But I would say on average, I would say 50 feet is probably a pretty good average. That site that I referenced in Texas, which is only going down to 30 feet, would probably be on the shallower end of where we've used these techniques.
Great. So moving along through the process of pre-drill, what type of injection tip do you use in the pre-drill methodology?
Yeah, that's a good question. So, I think I mentioned it earlier. We do try and match up our injection tips with the individual lithology, but so you can influence the exit velocity coming out of your injection tip, because we've got, if you've got a known flow rate coming down through your injection hose, and you alter the number and say the diameter of your injection holes that are in your injection tip. And just, I didn't show a picture of what the injection tips look like. It's a jetting tip. I mean, if you're familiar with the GeoPro model, which is 4 1/4-inch ports, we use that, but we also custom make our own, or we use other ones as well that have different numbers of holes with different diameters. But in most situations, we're going to want to go with a pretty high exit velocity, so we'd probably go with a smaller diameter and fewer number of holes. Try to go with a higher exit velocity to be able to make sure that we're getting it through the bentonite and out into that native material.
Great. So we got a couple questions here. I'm going to try and combine these into one. This revolves around post-injection, I think, and also regards to the I guess abandonment of the point.
Mm-hmm.
So following injection, is bentonite used to decommission the borehole, and do states or other regulatory agencies have issues with you leaving bentonite in the ground?
Well, it's obviously going to be state specific. Different states have different abandonment regulations, and so that may come into play whenever you're deciding whether or not to use this approach. I would say the projects that I've been involved in, we've used bentonite to re-abandon, if you will, each of these locations, and the regulatory body has been fine with leaving the bentonite hole plug in, and using that as the borehole abandonment. So I know, there are, depending on where you sit geographically, you might have to use cement. And if that's the case, then, maybe this works, maybe it doesn't, as whether or not this kind of technique is going to make sense for you, for your site. But I would say most, I mean, I don't know, Derek, if you want to chime in on that. So Derek's based on the East Coast, so I don't know if you want to chime in. I mean, have you had any issues out where you are?
No, Mike, none that I recall. The rest stop example you gave, that was Massachusetts. We didn't have issues doing it there. New Jersey, we've done it a good bit as well. Didn't have issues there. You mentioned a couple sites in the Carolinas. I can't think of any off the top of my head where the method wasn't approved. I mean, naturally, the bentonite, or even an improved bentonite grout, is certainly going to prevent cross-contamination and migration post-installation and injection. It could be a concern. I know there was a discussion on some sites over the mix, so to speak, that becomes that bentonite column. But is it chips? Is it pellets? Does it include bentonite grout? Things like that. So that could, as you said, Mike, that's probably a site-specific question, but we haven't really seen issues or concerns with it. Now, I think the one thing I will call out is you did show the site in South Carolina where we pre-drilled. We did have to telescope casing through multiple units at that site to make sure we cased them off and prevented vertical migration between those zones. But other than that, we haven't seen issues with contaminant migration using this. Naturally, bentonite is used to abandon a lot of boreholes that we put in the ground anyway, so I don't expect we'd see a lot of pushback from any regulatory body in using that, using this method.
Right. Yeah, like I said, depending on where you are, to the person that asked that question, if you maybe want to, if you have a state-specific example, I showed you the map earlier where we've used this technique. If it's in a state that we haven't worked in, reach out, let us know. We can talk about it.
Great. Um, I got one or two more questions here. I do want to make a note there. There's two questions about using this process for site characterization and can it be used with high-res tooling? Um, that's a pretty complex question and probably could be asked offline. We do have at AST, we have a gentleman named Ed Creedon who's joined us recently, who's an expert in that realm as well. So that might be a good question to bring him into. So there's one or two of you that made a statement about characterization. We'll get you connected up with Ed and our team to talk about that. I
Yeah,
think
I mean,
probably,
yeah,
yeah,
I
go
mean, I
ahead.
can, no, I can comment. I mean, you look at the site in Nebraska, the Atlas site, we used, as part of the well installation for the additional wells we put in, to monitor the pilot test, we did soil sampling, the CMT well, which was the multi-channel well. So if you're looking at, trying to get, that was, those of you that aren't familiar, looks like a pizza pie, and it's got different channels. So it's got 6 on the outside, 1 in the middle, and you can create those. You can sample whatever zones you want, and so that would be, but you can use those techniques, but high res, the high res tools are, they've improved significantly, and you can hammer on those a lot more than you used to. But if you're getting direct push refusal, I don't think you're using traditional high res site characterization like MIP, OIP, UVOS, that sort of thing. Unless you're trying to get through, you're using this technique to get through a zone. So if you've got like a shallow caliche with something below it that you can direct push through, then you could use this shallow and push that through and then fire it up once you get on the other side. But if you're talking about like a weathered bedrock, I don't think you're going to be using traditional high res tools. But again, we can probably have that conversation offline.
Yep, all good points. Um, let's go with this question to keep the conversation going just a little bit longer. Is pre-drill cost effective at smaller sites, or is this something that I can only use if I have a larger scale site that's impacted?
No, we've certainly used this on quite a few sites that are shallow. So I joined AST about 6.5 years ago. One of my first projects out here was a pre-drill site, just one well outside a dry cleaner, and we had a weathered unit that we couldn't direct push into, so each hole was pre-drilled. That was 12, 15 injection points, relatively shallow, maybe going down 25, 30 feet. So yeah, I think it's scalable. I mean, the problem is that your options become limited, even more so on those sites, I think. And so I think for some small dry cleaners, we've used this on some corner gas stations as well. So I think it's scalable. It's just you have to account for that additional drilling cost. Besides that, on our end, everything is the same. So.
Okay. I think this is probably a good question to wrap up with. Again, if we don't get to everyone's questions here, we'll reach out to each individual after this presentation and in subsequent days. Question here from a participant. I have a weathered bedrock and bedrock contamination issue. Is this something that I need to address separately from bedrock, or is this program couple up with a pre-drill program? Or excuse me, bedrock program?
Yeah, we've actually and out in Derek's neck of the woods, I know that's one site where we've done pre-drill on top of bedrock. Where we've got packer applications down in the competent material and a pre-drill on top of that. So I think yeah, you can totally combine the techniques. Just have to look at the site. So that site was in New Jersey. Trying to think, I'm sure that there are others out there where we've done that. I know there's probably just a handful of those, but you can absolutely combine those techniques. Or, I mean, you could, if you wanted to piecemeal them, we've done that as well, where we've done, sites where maybe we use traditional direct push down to refusal, and maybe you have a pre-drill kind of intermediate zone, if you will, and then down there you've got competent bedrock. So I know, like out in your way, Derek, there's a lot of sites that sort of fit that.
Yep.
Fit that
Yeah, I
site,
mean,
yeah.
that's a good point, Mike. And then as you pointed out, a transition zone, a weathered bedrock zone, saprolite, using this method that you've described, the injection program looks a lot more like a direct push overburden soil program than it does a bedrock program. So if you did bring us a type of site where you're dealing with both weathered and fractured bedrock contamination, there's potential to reuse a number of drive points and boreholes. But the one thing I will say is once you move out of the weathered overburden, weathered bedrock and overburden units, you're getting to the bedrock, your spacing for these injection points steps out a decent to a significant amount, depending on the site and the type of bedrock. So, there could be instances where we're nesting borings together, or we're trying to reuse some of these points multiple times in different units. But I would say when you do get to the competent bedrock part of that site, or in sites we've done up this way, the biggest difference is we need to move to an air rotary or sonic drilled borehole, and then we start to involve some geophysical tooling. Actually, last two webinars previous to this that Mike pointed out, we did cover that a little bit. So I encourage people that are interested in that to look at those two. Again, we can reach out to each of you with a question here as well. I think we've covered a good bit of topics here, Mike. We're about 45 minutes in total. I want to turn it over to you to wrap it up.
Yeah, thanks, Derek. Thank you, everyone. I know this is those of you that are still around. This is the year of the webinar, and I know you've been on more of these than you probably have been in your career. So thank you so much. We know your time is valuable. So thank you for joining us today. If you have any questions, there's my information as well as Bob Elliott at RPI. And have a great holiday, everyone. And we'll see you in 2021. Thank you.